In this particular video, we're going to preempt electricity, question that you can be asked in electricity, the approach that you're going to use in order to answer those questions. If you're doing Edexcel, Igcse Physics, this video is going to be very, very helpful for you so that you can be able to earn the best. Electricity is a very, very common question. So we're going to see how are you going, what are the skills you need, what are the concepts that must be on your fingertips when you are doing questions on electricity. Here we're going to try to understand how current in a series circuit depend on the applied voltage, and also we're going to look at questions that have been asked before. Now, going to the first question, we're told the circuit below shows a resistor connected in series with a cell and a switch. We have resistor X and the switch is open. There is an electric current in the circuit when the switch is closed. Describe how another component could be added to the circuit to show that there is current in resistor X when the switch is closed. Here we are going to use different devices. We can be able to use an LED, we can be able to use an ammeter. So an LED or a bulb can be connected, which lights when the current is flowing through the circuit. If you connect an ammeter, ammeters measure current. So if you close the switch, you'll be able to see a reading. But the best way you are to respond to this, an LED or a bulb should be included so that you can be able to see light. And then in that way, when you see light, it means there's a flow of current. The electric current in the circuit is a flow of charged particles. Give the name of the charged particle that is as a result of current. Now this is going to be an electron. Electrons flow when there is a current, so it means the charged particle here is an electron which is negatively charged. When the switch is closed, the current in the circuit is 160 milliamperes. Take note of that. Calculate the number of charged particles that passes through the cell in 25 seconds. And remember, the charge transferred equals to current times time taken. So meaning we can be able to work out the charge transferred in these 25 seconds. And we are going to use the formula charge equals to IT, or current times time. Yes. So, writing the formula, we are going to say, because we are given the current and the time taken, we can be able to say charge equals to current times time, substituting what we know. But now remember, our current is in milliamperes. Milli means 10 times raised to power negative 3. So meaning for us to convert this value of current to amperes, we are going to divide that by 1000. And we shall have our current as 0.16 times 25. If you work this out, we are going to get 4 coulombs. So this is the total charge that flows in the 25 seconds. So what is the number of charged particles? Each charged particle has 1.6 times 10 raised to power negative 19 coulombs, and the total coulombs we have here is 4. So in order to get the number of the charged particle, we are going to divide 4 by 1.6 times 10 raised to power negative 19, and our answer is going to be 2.5 times 10 raised to positive 19 electrons. If you are finding value from this particular video, consider subscribing, and also you can give this particular video a thumbs up as a sign of you are enjoying you are learning something, you are able to benefit from this tutorial, please just subscribe, and also you can share to your friends. Back to the main agenda of this video. Resistor X in the circuit is replaced with resistor Y. So we were having resistor X, then we are removing X, we are replacing that with Y, and resistor Y has a higher resistance than resistor X. So what does that mean? We are going to have high resistance in the circuit, which is going to slow down, which are going to limit the number of electrons. So explain how the number of charged particles passing through the cell each second changes when resistor X is replaced with Y. So what effect does higher resistance have to the flow of charged particles? When we have high resistance, less charged particles are going to flow. Now for that reason, the number of charged particles is going to decrease, and in the long run, current is also going to reduce. There will be higher resistance, and therefore the number of electrons flowing will reduce, resulting to a decrease in the amount of current in the circuit, because current is the rate of change or the rate of flow of charge. So that is what you are supposed to respond at that particular point. We need to move now and change the gear to question 2, where we are told that the diagram shows an electric circuit containing component X and a lamp connected in series. Add another component to the diagram to measure the voltage of component X. Voltage is measured using a voltmeter, and a voltmeter is a high resistance component. So always a voltmeter is connected in parallel to any component. So in order to do this, we are going to draw it as shown there. Then we shall have the symbol for our voltmeter here. This is our voltmeter, and you can see it's connected parallel to component X. Yes, so that's what you are supposed to do in order to earn that mark. But if it's an ammeter should be connected in series with other components. Give the name of component X. Okay, before that, take note of that, of course, so that write it somewhere, save it for future reference. A voltmeter is always connected parallel to other components. So this component X is a light dependent resistor. If the arrows are pointing like that, is a light dependent resistor, but if the arrows are pointing out of the device, that becomes a light emitting diode. So can move to the next part. The graph shows how the resistance of component X changes with light intensity. Because component X is a light dependent resistor, it means its resistance is affected as the light intensity changes. So let us see, how does that graph look like? Yes, a very beautiful graph. You can see resistance on the y-axis, light intensity in the x-axis. Use the graph to determine the resistance of component X when the light intensity is 4 arbitrary units. So you need to go to where we have 4 arbitrary units on the x-axis, and then now from there we draw a line. We're using this graph to find resistance. So we're going to draw a line right from here. Then we move across like that. Then we read this particular point. So if you read, you need to understand the scale that is used on the y-axis. So if we read this carefully, it indicates that this is 1,700 ohms. The current in the circuit is 0.018. Calculate the voltage across component X at light intensity of 4. So now, we have already mentioned that, or we have already obtained from the graph that the resistance at 4 is 1700. Now that we are given the current there is 0.018 amperes, we can comfortably use the formula voltage equals to current times resistance, that is Ohm's law, in order to work out the voltage. So we shall multiply current and resistance, which now we can see we have 3.06, which is 3.06 volts. Yeah. Explain what happens to the brightness of the lamp when the component X is covered with a dark sheet of paper. Now, when it's covered, it means light is going to be limited, so the light intensity is going to decrease. So when light decreases, what happens? Resistance is going to increase. When resistance increases, current is going to decrease. When current decreases, voltage also decreases. When all these aspects, current and voltage, decreases, then the brightness of the lamp is going to decrease. I believe you are getting value. I believe you are really understanding these concepts. You don't have to cram this physics concept, but if you understand the knowledge behind it, it becomes very easy for you to reproduce, even if a question is changed in one way or the other. So the main agenda here is that you are to know when light decreases, how does resistance get affected in a light dependent resistor. And that is exactly what we have written there. Moving to the next question. Question 3. A teacher uses this circuit to investigate how current in a circuit changes with temperature of a room. Now, the previous question we were looking at a light dependent resistor. A resistor whose resistance is affected when light increases or decreases. Now we have another type of resistor which we call a thermistor. A thermistor is a type of resistor whose resistance changes with the change of temperature. Now, in this question, we are supposed to calculate the voltage across the thermistor. But you see, we have a thermistor and we have another fixed resistor which is 140 ohms. Now, in this case, the voltage that is supplied is 1.5. So the total voltage drop in the thermistor plus the voltage drop in the fixed resistor should be equal to 1.5. So if we add the two in the 40 ohm resistor, we are going to get 1.5. We have the voltage drop in the fixed resistor is 0.91. So we can be able to work out the voltage in the thermistor there. So to do that, we are going to say voltage in the thermistor is going to be what? V plus 0.91. So that will be V equals to 1.5 minus 0.91. And the answer is going to be 0.59 volts. That's the voltage in the thermistor. State the formula linking voltage, current, and resistance. Voltage equals to current times resistance. Very interesting. Calculate the resistance of the thermistor. Now that we know the current in the circuit is 6.2 milliamperes, and we know the voltage in the thermistor is 0.59, then using the formula V equals to IR, we can be able to work out the resistance of the thermistor. So in other words, we can be able to rearrange this formula and say resistance equals to V over I. Our voltage is 0.59. Our current, now look at the current, it's 6.2 milliamperes. We have to convert that to amperes by dividing that by 1000. We have to divide that by 1000, and finally if we work out this, we're going to get 95.2 ohms as our answer in that case. The graph shows how resistance of the thermistor changes with temperature. Now let us go down and get to see how beautiful is that graph. How cute is it? A very nice graph. Look at that. Look at that. Look at it. Resistance against temperature. So there are no values here, but the graph can be able to communicate a lot. Now suppose we were having values. We were having values. These are just I'm just thinking. This is in my mind. It's not there. I'm just thinking. I'm just imagining there were values. Then if I go on the temperature part, I draw a line to meet that curve. I go across, I'll have a resistance which is around 18, around there, because it's less than 20 years. And if I go to another temperature, higher temperature of 10 degrees Celsius, and then go across, the resistance will be 10. Oh, what has happened? So with high temperature, resistance is low. Oh, okay. So as temperature increases, resistance decreases. Oh, okay. Now describe the relationship between temperature and the resistance of the thermistor. Yes, I got it. As temperature increases, resistance decreases. So resistance decreases with increase in temperature. Is that okay? Alright, let's see what we are going to say here. Resistance of the thermistor decreases with increase in temperature. Now, in physics, we have different graphs. When you draw graphs, you can either get straight line graphs, you can get curves. Now, when you have a straight line graph like this in physics, it means the relationship between the two quantities is linear. The relation is linear. If it passes through is a straight line but passes through the origin like that, it means the relation is linear, and it's also directly proportional. Linear, and at the same time is directly proportional. So meaning when one increases, the other one increases at the same rate. But a scenario whereby you have a curve rather than a straight line, it means that's a nonlinear relationship. Yeah? So those are some of the things that are running in my head that were mentioned in class. So this is a nonlinear relationship. So temperature and resistance show a nonlinear relationship because this graph is not a straight line graph, it's a curve. Moving on, explain how the reading on the voltmeter changes when the temperature of the room decreases. When temperature decreases, what did we notice? Resistance increased. If resistance increases, current is going to decrease. When current decreases, voltage is going to be lower. When voltage is low, the reading of the voltmeter is going to reduce. This results to a decrease in the amount of current in the circuit, hence reducing the amount of voltage, which means now the reading of the voltmeter is going to reduce or decrease. Moving to question 4. A circuit shows a car battery charging from an alternating current supply. Sketch the graph to show how what is meant by alternating AC. AC is a type of current that is constantly changing direction. Now, in order to draw that, you need to draw that, identify the axis, and then you're going to draw a smooth curve like that. So meaning current is changing direction, alternating from positive, negative, like that. State the reason why the circuit contains a diode. A diode allows current to flow only in one direction. So this is to ensure current can flow only in one direction. The 12 volts car battery is connected to two identical filament lamps so that the voltage across each lamp is 6 volts. Draw a circuit diagram to show that. So we have two identical filament lamps. So in order to have it, we need to connect them in series, and they are going to share that voltage. When they share the voltage, they are going to light, and the voltage at that particular point should be 12 volts. So each of the bulb is going to get 6 because they are identical and they are in series. State the equation relating power, current, and voltage, and the formula is power equals to current times voltage. During exams, make sure you write your answers in full. The power of each lamp is 330 milliwatts. Calculate the current in a lamp. So we are going to use the formula that we have mentioned in above so that we can substitute. Remember that it was milliwatts, so you are going to divide by 1000. Those key areas, milli, kilo, mega, in physics are very, very important. Those are life-saving key points. If you forget, I don't want to say what is going to happen. I don't want to mention. Now, substituting this, we are going to have here 0. Yeah, divide by that. We have our volts, 6 volts. If we work out this, we're going to get 0.33 divided by 6, and finally we have our answer as 0.55 amperes as the current that is in the lamp. Going to question number 5, the circuit diagram shows a 9.0 volt battery connected in series with 250 ohm resistor and another resistor X whose resistance is not known. Draw a voltmeter on the circuit diagram to measure the voltage of resistor X. So how are we going to draw that? Can you draw it first? Draw it. Then once you've drawn, you check with what we have here. Can you draw it? Alright, let's go ahead. This becomes what? A voltmeter is always connected parallel to any component or to any device. So for that reason, since we are connecting it for resistor X, then we are going to add it there. Yes, we can be able to add it here, and then this is our voltmeter. Another student was asking me, can we be able to draw it such that it's inside the diagram? Yes, we can, but ensure that it's connected parallel like that. The current is 0.012 amperes. Calculate the resistance of X. So what are we going to do here? First, I want us to approach it in this manner. Let us first work out the voltage in 250 ohm resistor. Current is the same everywhere in a series circuit. Current is the same in every component in this circuit. So current that is going through 250 ohm is 0.012. In X also is 0.012. So we can be able to use that current and the resistance of 250 ohms to work out the voltage in this 250 ohm resistor. So for us to do that, we gonna write voltage in 250 ohm resistor. Voltage equals to IR, so current is 0.012 times 250. Then our answer here is what? 3 volts. Now that we have 3 volts, then you need to remember one key point. The voltage drop in 250 ohm resistor plus the voltage drop in the X, in resistor X, if you add them, you are going to get 9 volts. Now, voltage in the resistor X, is going to be what? So 9 minus 3, which is going to be 6 volts. Having 6 volts, and we know the current in X, we can be able to find resistance using that formula, and our resistance is going to be 500 ohms, which we are going to transfer there just to make the examiner happy, because there are no extra mark for transferring that answer there, but just to make the examiner have a good mood with you while he's marking your exams. State what's meant by the term electric current. Electric current is a flow of charge, is the rate of flow of charge, and the charge that is flowing is electrons. When electrons flow, we say there's a current flowing. Give the reason why an LED, light emitting diode, is included in the circuit. This is meant to light, then to indicate there is a flow of current. There is current. The LED light to show there is current. Yes, so take note of that. It should be the LED light to show there is current. We need to change that. So how is it going to be connected? It should be connected in series with other components. But remember, when we were talking about a voltmeter, it should be connected parallel. I've kept on repeating this so that you can get to understand. That's a life-saving point. Voltmeter is connected parallel. Now, let us look at another question here. Another component of the circuit diagram to measure, add another component. Already we have mentioned that. Diagram 2 shows different electric circuit containing 3 different lamps. Calculate current I. Check I where it is. Check I where it is. So, here we have 3 lamps. We have lamp I, lamp 1, that is the first lamp. We have the second lamp. We have also lamp 3. But you see now all these lamps are taking in current. The first one is taking 0.2. The last one is taking 0.3. But the current that was running from the battery was 0.6. So it means if you add 0.2 plus the missing current I1 plus 0.3 must give us 0.6. That's the thing you need to understand. Current splits in parallel circuits. So for that reason, we are going to say this current should be addition of this current 0.6 amperes should be equal to the sum of the three that is underlined. So we need to try to work it out. So which means our current I is going to be 0.6 minus 0.5, yes. Then we shall have our current I being equal to 0.1 amperes. That is 0.1 amperes. Current 2 on the other end is going to, because now after current has branched into those divisions, when they rejoin, current 2 will be equal to 0.6. They will combine again so that we have 0.6. So current will rejoin again and we shall have 0.6 amperes. Explain which lamp is the brightest. Now, when components or devices are in parallel, it means they are going to have the same voltage, but current is different. Yes? So how are we going to reason here? Lamp 3 is the brightest because voltage is the same. Remember, voltage is the same in the three lamps. But lamp 3 is the one that is drawing in the largest amount of current. So the first statement we are to say lamp 3 is the one that is going to be brightest since voltage is the same in all the lamps and current is greatest in lamp 3. So power in lamp 3 is going to be higher. Yes, because if you calculate the power, you are going to have a higher value. And the higher the power, the brighter it is. Those bulbs which consume a lot of power, they are bright, they light bright, they become very bright, they look bright. So we are going to say lamp 3 is going to be the brightest, and those are the reasons that we have mentioned there. We have a photograph that shows means operated decorative lamp X. Lamp X has 7 identical lamps that are connected in series. Give a disadvantage of connecting the lamps in series. Disadvantage of connecting lamps in series is that if one of the lamp goes off or they develop a volt, then we are going to have an open circuit. So you realize that if one spoils, we are going to have an incomplete circuit, and then the rest of the bulbs in that lamp are going to go off. So that is why you find that most of the time in our homes, lamps or lights are connected parallel, so that if one room is off, then the rest of the room will be still on. The bulbs in other rooms will be still on. We cannot be able to connect lamps in series in our houses, because if we have a scenario whereby one lamp is destroyed, is broken, has blown, we are going to have a blackout in the whole house. So that's one of the disadvantages. And however, even if this is a disadvantage, we also have advantage of connections in series. If you have less wires and you want to develop a circuit, this is the best method, because it usually takes very few wires and the connection is actually easy. The connection is not complicated. So if maybe you realize that the one component is not working, you can easily follow through because the connection is actually easy. Another reason is, or another advantage is that you can be able to operate different components using just one single switch. Yeah. So it's a bit convenient. So here you are supposed to just give one answer. You can even give two, but during exam just give one, the one that you are very sure of, to avoid wasting a lot of time. Moving to part C, each lamp has a working resistance of 390 ohms. The voltage across each bulb is 33 volts. So each bulb has a resistance of 390. Each, underline that. Voltage across each is 33. But the bulbs were 7. State the formula linking voltage, current, and resistance. And you are supposed to identify that. You can see now if you count them 1, 2, 3, 4, 5, 6, 7 arranged in series. Okay. Voltage equals to current times resistance. Now calculate the current in each bulb. We can be able to rearrange our equation. Current is V over R, and having that, we shall have our answer as 0.085 amperes. That is the current in each bulb. Calculate the energy transferred to lamp X when it's used for 2.5 hours. So let us calculate the energy transferred to each lamp, or one lamp. We know power, or energy rather, equals to IVT, current times voltage times time. And remember, time must be in seconds. That is very key. So we are going to multiply by 2.5 times 3,600 in order to convert those 2.5 hours to seconds. Now, if you work out this, we are going to get our answer as what? Let us use our calculator and see what we are able to get here. So if we work out this, we're going to get our answer as, remember the number of bulbs was 7. So this will be 24.5 times 7, because we were having 7 bulbs in lamp X. Count them. How many are they? Count. 7. Yes, 7. Okay. Now let's go back and do the calculation and see what we are going to get. And this is going to give us 176,715, which is approximately 180,000 joules of electrical energy. Okay, so far we've come to part D, whereby we are told that another decorative lamp Y uses 5 of the same 390 ohm bulbs connected in series. So the number of bulbs have decreased in this second decorative lamp Y. So if we are going to have less bulb, it means each bulb in Y is going to get higher voltage, higher amount of voltage compared to lamp X. So explain how the brightness of a single bulb in Y compares to the brightness of a single bulb in X. How are they going to compare? What are we going to do here? What are we going to say? Brightness in Y is greater than lamp X because each lamp, or energy transferred in each lamp in Y, each bulb in Y is higher. There is more energy transferred in Y because we are having less bulbs, and each bulb is going to have a large amount of voltage. So we are saying that each bulb in lamp Y will have a larger voltage since there are fewer bulbs to share the voltage. There are fewer bulbs to share the voltage, and for that reason, we are going to have it bright. A toaster is an electrical device used to toast bread. Okay. It's almost lunchtime. You can see it's 12:24. And when we mention something like to do with food. It means I have to summarize this and I go to have something. Now, if I go, the toaster contains thin metal wires, and these wires are connected parallel. The wires transfer energy to the bread by heating and radiation. Give a reason why wires in the toaster are connected in parallel. Number one is that if one of the wire develops a fault or is broken, the rest of the wires will continue heating the bread and people will be enjoying. So for that reason, if one wire fails to work, the rest of the wire will continue working, unlike if they were connected in series. State the formula linking power, current, and voltage. We have mentioned this in the previous setup of questions, so I believe that is just a walk in the park. The power rating of a toaster is 2.8 kilowatts. Kilo. That's an area you have to be very careful. Kilo means 1000, so we have to do that conversion and have it in watts. Now calculate the total current in the toaster. Current is power divided by voltage. If we do this, we're going to get the current being 12.2 amperes in the toaster. The next question, the toaster contains 48 thin metal wires. Calculate the current in each of the thin metal wire. We have calculated the current. Calculate the current in each of the thin metal wire. We have already calculated the total current in the toaster to be 12.2. So what does that mean? For us to work out the current in each of the thin metal wire, we are going to take 12.2 divide by 48, and if we work out that, we are going to get 0.25 amperes. At that point of time where we are talking about a toaster, because the time I allocated for this tutorial for electricity, question to do with electricity and mains electricity, energy in electric circuits, this marks the end of our tutorial. If you are new, consider subscribing, and if you know this can benefit your friends, you can be able to share to them.